Hello, welcome back. In the last lecture, we explored the machine exception delegation register. We got to know that the machine exception delegation register can affect the execution flow of the exception in RISC-V architecture. If we modify the specific bit field inside the machine exception delegation register, the exception can be delegated to supervisor mode. Now, let's outline the debugging practice in this lecture. The first, you're going to see how the exception occurs in the user mode by running broken instruction. Here is the broken machine code in the user mode. Then you're going to see that the privilege mode switched to the machine mode by moving to the trap handler. So this is the default setting in RISC-V architecture. And then you're going to see that the specific bit field inside the machine exception delegation register will be modified. And then you're going to see that how the control flow can be changed after we modify the bit field inside machine exception delegation register. Later, you're going to see that the control flow can be changed from user mode to supervisor mode. Now, let's get started. So here, what you can see is the TRACE32 debugging program. This window is a register window. You can see the set of the general purpose register, and this window is instruction window. In the instruction window, you can see the address and the assembly instruction. But this gray bar indicate the address that is held in the print counter. In this address, what you can see is the broken machine code, that is 0xFFFF. So now, I'm going to attempt to run this machine code. You're going to see that the exception will occur. Here we go. 1, 2, 3. So first thing you can observe is that the privilege mode switched from the user mode to the machine mode. Please look at this. The privilege mode is machine mode. And another thing you can observe is the print counter is moved to this address. So this is the trap handler in the machine mode. Now let's look at the value of the machine cost register. So for this, I will navigate the menu from CPU to peripheral. Then I'll go to controller status menu. Then go to machine trap handling. So please look at this. So machine cost register is updated to 2 value 2. Please look at this 2, because we attempt to run the broken assembly instruction. In other words, exception occurs due to illegal instruction. So better understanding, so I'm going to revert what I did by running alt-undo assembly instruction. Before this, I'm going to modify the value of mcost register. Now, the value of the mcost register is 0. Please look at this. Then we'll use the alt-undo command to revert what I did, and in this lecture, that is to run the machine code. Please look at this. Now, I move back to the state before running this broken machine code. Now at this point, the machine cost register is 0. Now we'll run this instruction again. So please pay attention to the value in this machine cost register. Please look at this. So machine cost register is updated to 2 value. Now let's use the alt-undo command to revert the disassembly instruction. Please look at this. Now we move to the state before running this broken instruction. The current, the privilege mode is the user mode. Right now, what I'm going to do is to modify the second bit inside machine exception and delegation register. So here is the bit field inside machine exception delegation register. So here I will set this bit field to 1. Okay. Now at this moment, the second bit is 0 by default. I will click occur button to modify the second bit inside machine exception delegation register. Now I'm going to run this instruction. But please look at this. The privilege mode switched to the supervisor mode instead of the machine mode. And then the parent counter is moved to the another address, that is handle exception. Handle exception is the name of the trap handler in Linux kernel. So important thing we can observe is that once we modify the second bit inside this register, the privilege mode switched to the supervisor mode instead of the machine mode. In other words, this exception due to illegal instruction is delegated to the supervisor mode. Please look at this. Now, let's continue another interesting debugging practice. So I will use this command again, alt undo, to go to this address. At this point, as you can see, the current privilege mode is the user mode. Now, what we are going to do is to set the second bit position to 0 instead of the 1. So I will click on occur. So this is the default setting of machine exception delegation register. So we can expect that the privilege mode will be switched to the machine mode because this is a default setting. So let's try it out. 1, 2, 3. Please look at this. Current privilege mode is the machine mode, not the supervisor mode. The parent counters is moved to another address. As you can see, after we modify the second bit position inside this register, the exception, this type of exception is taken to the machine mode because it is default setting. So in this debugging practice, you got to know that the bit position of the machine exception delegation register can affect the workflow of each type of exception. Now let's summarize the debugging practice in this lecture. So in the default setting, so all of the exception is taken to the machine mode. So as you can see, when we run the machine code in the user mode, the exception was taken to, this kind of exception is taken to the machine mode. But right after we change the second bit inside this register, so exception is taken to the supervisor mode instead of the machine mode. This means that this control status register could be used as interface to change the control flow of exception. In other words, it is interfaced to the specific type of exception to be delegated to the supervisor mode.